Now in this video I'm just gonna basically talk about domains and a range of a function. Now if you look at this function here, you have y equals 1 plus the square root of x divided by 4 minus x squared. Now basically the first thing I'm just going to focus on the domains here. Now the domain, in this case, there are x values for which y is defined. The domains will be all x values for which within an interval for which y will be defined. Sometimes they can specify the domain and sometimes they may not. But now if you look at this function and they ask you to find the domain of this function, then you have to consider the following. Now consider the numerator and then consider the denominator. Now in mathematics you're not allowed to divide by 0, so that means that 4 minus x squared cannot be 0. Now we can only take the square root of a 0 or a positive number. That means that the square root of x equal or greater than 0. So you can link the two. We must link the two in order to give the domain of y. So how do we do that? So first you solve for 4 minus x squared equals to 0. So you have 4. I know I said it's not equals to, but first you try to solve it as it's an equal sign. So you have 4 minus x squared equals 0. Then you can factorize this into 2 plus x into 2 minus x. And that's how you can factorize that one there. Then from here you can have a solution x equals minus 2, and you can have a solution x equals 2. But now this is not part of the domain. This should not be part of the domain. But now this is not the final answer of this. You must link the two. You must be able to link the two. Now from this you can get that x is equals or greater than 0. That's the solution to this one. Now you must be able to link x equal or greater than 0 and the 2. So I'm just going to draw a number line from here, and I'm going to represent these values there. So I have minus 2, and 0 will be somewhere between minus 2 and 2. And from then we know that the square root is only defined for x equal or greater than 0. So we have this point. So that means we can neglect minus 2 because we already have the interval that x is greater than 0. But we know that the denominator in this case will be 0 if x is equals to 2. So that means that we must have an open point here. So that means that x is not equals to 2. X is greater than 0. So the domain is that x is greater than 0, but x is not equals to 2. So is the element of numbers between 0 and 2 where 0 is included and 2 is not, and it also proceeds to values of x greater than 2. So that's the domain of this function. That's how you can evaluate the domain of this function. Now, do you get the main point on what we do when we try to find the domain of a function? Let us see on the next problem if we can be able to find the domain of the next problem. Now suppose we have a function defined by the square root of 16x minus x squared, and we're looking for the domain of this. Now the domain of this will be, we know that the square root from the first problem we just evaluated, that the square root must be greater or equals to 0. So the inside, you just said the inside equal or greater than 0. So that means that 16x minus x squared can either be 0 or any number larger than 0. So then you just factorize this now. So you can basically factor by x, then you'll have x, then you'll have 16 minus x. Then you look for the interval for which this will be positive. So you'll have the values 0 and 16. So from here you can be able to find your interval. If you substitute, or you can basically realize that this is a parabola that slopes downwards like this. Then these points are included here. So you know that this is positive and the rest of that is negative. And then remember that this must be either, the inside must either be positive or 0, making the domain to be this interval 0. X will be between 0 and 16. The other way you can write this is x is what? Is the element of 0 and 16. Numbers between 0 and 16. So Note that 0 and 16 are included. For inclusion, you make the square bracket, and if it's not included, then you'll make a normal bracket or a small bracket. Then that's how you can basically find the domain of a certain function. Now, what about the range of a function? Now, basically, this is the graph of the inside function, and at some point we'll have a peak. We know that the minimum of the inside will be either 0. This can be equals to 0 if you substitute 0, and that's the lowest possible value you can have in the square root. And that means you have to find the maximum value of that, and then you take the square root of that. Then you'll have the range of that. Now let's look at this function. What is the range of this function? How can we find the range of this function? Now, we know that x squared, if you look at x squared, if you try to graph x squared, you'll have the graph that looks like this. So the minimum value of x squared is 0. If you graph x to the fourth, you'll also get the similar graph. It's just gonna be something like this. It's gonna be something like this. Okay, let me just, it's not to scale. You're gonna have the graph x squared, and then you're gonna have the graph which passes through, they intersect at -1 and 0 and 1. So this will be not to scale, right? But they intersect at -1 and 1. The inner graph, it's x squared, and the outer graph is x to the fourth. Notice that both have a range with the minimum of 0. But then realize that the minimum value of this will be 0, because it's just a sum of that, the minimum of 0 for both of them. And then notice that you have an extra term here, -4. So how you can evaluate the range of that, you can then say that y is the elements of real numbers greater or equals to 0. So that's the range of this function, because it's just going to slope upwards. It's just going to slope upwards. This is an even function. Yeah. Oh, sorry, it's not an even function because of the -4. But if we didn't have -4, then it was going to be an even function. But then this function is neither even nor odd because of that -4. So now, that's basically how you can find the range of this. And now suppose that you have another graph, y equals x to the power 5 plus x to the power 6. Now suppose you're looking for the range of this function. Now this is where you have to apply derivatives of that. You have to find the derivative. You have to apply the derivatives. But then you can basically see that the highest degree of this, it's 6. This is a polynomial of degree 6. And then now, if you focus on this and you take the derivative of that, then you'll have 5x to the fourth plus 6x to the fifth. Then if you set the derivative to be equals to 0, then you'll have 5x to the fourth plus 6x to the fifth equals to 0. Now, if you try to find the critical points of that, so you'll have to have x to the fourth into 5 plus 6x equals to 0. So that means you have x equals 0 and x equals -6/5 as the critical points of that function. Now, if you take the second derivative of that function, so it's basically derivative test. So now 5 times 4, that's 20, then you have 20x to the third plus 5 times 6, that's 30, so you have 30x to the fourth. Now at 0, this is 0, so this is not a turning point of that function. But now at -6/5, then if you substitute -6/5 here, you're going to have, okay, we can factorize this. Let me try to factor the second derivative. Then we can have what? We can have 10x to the third into 2 plus 3x. So you have 10x to the third. This term is not there. So you have 10x to the third into 2 plus 3x. Now, if you substitute minus 6 over 5, this is going to be negative. This term will be negative. And now, the inside 2 plus 3x, you're going to have 3 times 6, which is 18. And then 18 divided by 5 is definitely greater than 2. Then you'll have also a negative here. And then if you have negative times negative, then you have positive. Now, if the second derivative is positive, for which the first derivative is 0, that means you have a minimum value of that. So that makes the domain of that, the range of that to be y equal or greater than that function at minus 6 over 5. So you'll have to just evaluate that. You'll have minus 6 over 5 to the third plus minus 6 over 5 to the power 6. Then you can simplify this, then that will be the range of that function. That's how you can evaluate the range of that function. So in most cases, people struggle with the domains, but then if you can be able to define domains and range, then you can be able to solve that one. So the whole point of this is to find the values of x. If you're looking for the domain, you're looking for the values of x for which y will be defined, and if you're looking for the range, then you're looking for the values of y given by the set of the domains. Did you hear me what I said? The domains of a function, domains are sets of x values for which you will get the defined y value. Now the range is all possible sets of y values given by the domains. I hope that's clear how you can be able to distinguish between domains and range. Domains, we look at the independent values. In most cases it's y, it's x. In most cases it's x. Domains, in most cases it's x in terms of x, and the range is in terms of y. Now let me explain again. Domains is all sets of values, independent x values for which the graph will be defined. Now the range is all possible sets of values given by the domains. So that's how you can evaluate that function, evaluate the undefined or defined states of a function. Then you can be able to give the domains and range. Like in this case where you have x divided by 1 minus x, how do you find the range and domain of that? Can you be able to find the range and domain of that? So the domain is all sets of real numbers excluding 1. That's because if x is 1, the whole of this becomes undefined. Now how do you find the range of this function? Now you're gonna manipulate this to be what? 1. We have 1 minus x in the denominator. That means we can have 1 minus x also in the numerator. We have 1 minus x. I'm just going to manipulate this, but notice that initially we have x. The only way you can get that is if you manipulate this equation there. But notice that we'll have a problem here. Now how you can do it is correspond the denominator with the numerator. Now I'm gonna have something like this. I'm gonna put a negative sign here. I'm gonna put a negative sign so that here negative into positive, you have negative. That means we subtracted 1. That means you can add 1. And negative into negative is positive, is this x. So basically it doesn't change anything, it's still the same function. But notice now that that function will reduce to 1 minus x divided by 1, negative into 1 minus x divided by 1 minus x is gonna be minus 1. And then you'll have minus 1 plus 1 over 1 minus x. So what is the range of this function? Notice that this cannot be 0. This cannot be 0, meaning that y cannot be minus 1. So that makes the range to be y being all sets of real numbers, excluding that y can be equals to minus 1. If y equals minus 1, you won't be able to solve for x. So that's basically how you can find the range and domains of a function.